Hi, I'm Dr. De Bruin, and this is a run-through of how to answer an exam question from the bonding topic of AQA A Chemistry. This one is about the different melting points of substances based on their structure and bonding. The table below shows the melting points of three substances. We've got potassium fluoride, fluorine, and hydrogen fluoride. Explain why the melting points of these substances are different. You should refer to the structure and bonding of each substance. So this question is really similar to some questions that you would have encountered at GCSE, and just like at GCSE, a lot of quite smart people who know quite a lot of chemistry are going to lose a load of marks because they're going to use one particular word in an inappropriate context. So when you're talking about potassium fluoride, you are not going to use the word molecule because this is not a molecular substance. This is like a classic GCSE ionic substance. You've got something from group 1 and group 7. It couldn't be more ionic if it tried. And if you use the word molecule, then even if you've said that it's ionic, you're going to end up forfeiting marks. So let that be a word of warning for you. So we've just said that potassium fluoride is an ionic substance, and therefore it's going to form a giant ionic lattice. So that's what we mean when we say the structure. So the bonding is ionic, and we can talk about how that ionic bond forms, and then the structure is this giant lattice. So the ionic bonding is actually a strong electrostatic force of attraction, and remember we have to use that word attraction, and it's attraction between these positively charged potassium ions and the negatively charged fluoride ions. And that electrostatic force of attraction, because it is so strong, needs a huge amount of energy to overcome, and that is why the melting point of potassium fluoride is so high. Now, in contrast to that, fluorine is a small covalent molecule. So here we can use the word molecule because it is a molecular substance. And fluorine doesn't have any polar bonds, which kind of makes sense because it's two atoms of the same element bonded to each other. So there's obviously no difference in electronegativity because they're the same element. So that's like the definition of a non-polar bond. And therefore, the weak intermolecular force between those fluorine molecules is just going to be van der Waals forces, which are our weakest type of weak intermolecular force. And so it doesn't take much energy to overcome those at all. And we could even put it a bit more explicitly, we could say that ionic bonds are stronger than weak intermolecular forces. So a really common mistake that we see in similar questions to this in the past is that students talk about the different substances individually and they don't compare them. So we want to make sure that that we're actually saying, oh, the ionic bonds are stronger than the van der Waals forces or stronger than the weak intermolecular forces. So then we can think about our third substance, which is hydrogen fluoride. And again, this is a small covalent molecule. Now we need to think carefully here because we're going to be thinking both about the molecule itself and its size, but also about the type of weak intermolecular force between molecules of this substance. So hydrogen fluoride is a smaller molecule than fluorine, and it does have fewer electrons. And that will have an impact on the size of the van der Waals forces. So its van der Waals forces would be smaller because it has fewer electrons. However, that hydrogen fluorine bond is extremely polar. It's like the definition of a really polar bond because of this massive difference in electronegativity. And therefore, hydrogen fluoride is going to have hydrogen bonds between the molecules. And those hydrogen bonds are stronger weak intermolecular forces than van der Waals forces. So they're going to take more energy to overcome, and therefore hydrogen fluoride has a higher melting point than fluorine. This type of question would be an extended response 6-mark question. So to get up to level 3, we need to make sure that we're covering all aspects of the question, and they're going to sort of artificially make sure that there are 3 different areas that we need to cover. So here we need to be thinking about the structure of each substance, the bonding of each substance, and the melting point of each substance. So our structures are the fact that potassium fluoride is a giant ionic lattice, where the other 2 are simple covalent molecules. And then the bonding, we need to have talked about the attraction between the positive and negative ions in potassium fluoride, and then the van der Waals forces in fluorine, and the hydrogen bonds between hydrogen fluoride molecules. And then lastly, we need these comparisons of the strength of these. So the idea that the ionic bonds are stronger than the weak intermolecular forces, and the hydrogen bonds are stronger than the van der Waals forces. Thanks very much for watching, and I hope you found that a useful walkthrough for this exam question. If you did find the video useful, then don't forget to like, subscribe, comment and share, and I'll be back with some more A-level chemistry revision resources soon.